A new motor from SkyRC for 2018, the Ares ProV2 competition. On the back it shows you they've got a whole range, modified and spec. Now the spec ones are the ones with the bigger non-magnetic core that they wrap the magnet around on the rotor, so generally has less torque, less Gauss, weaker magnets than these ones which have a thinner core, so more magnetic material. Interestingly, 13.5 and 10.5 also available in the modified version with the other rotor. Now what difference do you think that makes? Well, handily they give you some information on the left, and it shows you the torque available as stars. So these two are 7.2mm. The 12.5 is what's generally fitted in all stock legal blinky class sort of motors, and just 3 blobs, 3 stars for torque, high RPM. Now they talk about high RPM because a weaker rotor in theory gives you a higher RPM motor. In practice it doesn't always pull. Offload it will, but not onload. So this is the weakest one. The 5mm core ones, 12.5mm, same diameter, they talk about higher torque, and then the 12.8mm, which is obviously a bigger diameter, more magnetic material, more torque. That will slow down the motor, so it won't rev as high, but it will pull very well, so it might just go as fast or faster on some tracks, smaller tracks, windy tracks. But they're not available in the spec motors. So that's a lot of information there. I've got two here, the 17.5 spec and a 13.52 modified, so it'd be interesting to see what the difference between that rotor is and the rotor in here. I'll take them apart and measure them all up on the Gauss meters, etc. So I want to check this out. We've got a nice picture on the front. So opening this one up, it's motor, there's a sensor lead, fairly short. Looking at the motor here, it's black with nice exposed aluminium edging. First thing we notice, they've got cutouts for cooling, but you can see the plastic former inside, especially here, which is blocking the cooling vents up. The plastic formers basically went out at least a year ago on the top quality motors to increase airflow and reduce a part that's not required, enables you to wind the windings tighter without the plastic being in the way. So it's a bit behind the times. They use it probably to make it easier to manufacture, but it's blocking up the holes here and here, which is a shame. I can see that already. The tags on top are fairly solid looking, solder tags, lifted quite a long way off. They're standing quite high proud compared to the Phantom. There's an insulator here which is normally paper, which is now plastic and or rubbery sort of thing. I think it's to stop you shorting out between the tag and the case when you make a mess of solder in it and let the solder run down. 7.5 turns etched onto the dark, very dark laminations. You can see the winding on the front. You've got the collector plate is fairly small and quite thin. You can't see it, but it's thinner than a lot of others, and that's shown up by the paper gasket, which is for insulation to stop the windings rubbing and shorting out, and that looks much bigger than some of the others. especially the Phantom one, is and I think the R1's the biggest, so it's huge. The case, you can see it's one piece down to the back. It's not a removable front like this one is, doesn't come off. It goes all the way down to the back in one piece. I don't know really the advantages of that unless it saves them on manufacturing costs. M-bell, you've got a plug there and a plug there, so it's two sensor inputs. Some information on the end written pretty small. Dual sensor SkyRC, you can read it. The timing, nice size, similar to the Phantom, perhaps a bit even better, easier to read. 10, 30, 50, and a mark in this silver ring, which is the pointer. Some silver screws from the back, like the Phantom. They screws from the back into all the way down and screws into the front. You can see the ends. So I'll take it apart, do some measurements, but before I do that, I can tell by turning this what strength is the rotor. Well, it doesn't feel very strong actually. There's no writing on there. Sometimes there's some engraving telling you what the rotor is. So the test is hold the shaft, spin. Not very strong. I'd say that's quite weak rotor. Not very good for high competition use in my opinion. On the tracks that I've seen, maybe some tracks it's fine. Shimming, good, very good shimming. Compare that to this one, strong rotor, how quickly that stops. So I don't like that already. Be interested to see whether this one, which got a different rotor in it, how strong that's going to be. Looking at the 13.5 turn Pro one, but this is this one here, the so-called modified one, which is supposed to have a much stronger rotor according to this, high torque compared to the spec one. So the spec one was that weak, and this one is stronger. Not as strong as the Phantom though, but definitely stronger. So I'll check both these by taking them apart, otherwise they're identical in appearance except 17.5, 13.5 written on them. I'll take this apart, do some measurements including the weight. Some of the motors, the Reedy I think has been the lightest weight we've ever tested. The Hobbywing now is the lightest, 169.3, pretty heavy. It's a bit out of date. The Reedy was only 145 for 17.5 turn. This is 169.3. The only advantage so far about this motor is that it's a budget motor. It's not that expensive. It's almost half, if you can pick it up in Hong Kong, the cost of one of the top range motors. We've taken apart the Sky motor. The stator is here. You've got well, it is riveted brass soldered plate. This is the plastic former I'm talking about. Here's here and here, but they put the winding round. It makes less room for the winding, so they have more. It's not going to be so tight, and it's going to be a high resistance. I'll check it in a minute. Quite a thin collector plate on the front. It's quite well soldered. What can you say? When I took it apart, a piece of this small piece fell out. I think it goes. I think it fits in there like that. It fits in just to fill that gap, but it falls out and You might lose it. This rubbery bit goes at the back. Now, sensor boards are very thin bit of circuit board, and you can actually rock it backwards and forwards. It's been conformal coated, which is good. Try and keep any water off it. And you can undo the 3 screws and move the plate on the back. Because the stator uses plastic former, it's you can measure the length quite easily. There's no epoxy in the way. So 20.26, 107.2. Anyway, the important rotor, it's got some writing on it, EASTAR, and then a number looks like 150119 perhaps. It's a slightly different design from other rotors. It's got this step part here, there's a washer, and there was another very thin washer on the front as well somewhere. Anyway, let's measure the Gauss. This is from the 17.5 with the weaker Gauss rotor. Minus 1247, so it's weak. 1253, 1247. We're looking for 14, minimum of 1400s these days, up to 1500 or higher. So that is weak. We knew it was weak. I'll test the other one, the 13.5, which has got the stronger rotor, and see what that is in a minute. The rest of this motor, I'll measure it up. There's the case, by the way, a thin case. It did slide off. That slides on. So not a very tight fit for transferring the heat between here and the case. Normally you want that as tight as possible, or tight as possible to transfer heat. Well, that's where it goes. If you make it tight, they can't get it on, so it's a production thing really. Quite a big bearing in this end, which is good. I'll measure the stack length in a minute. There's that washer. Just the shimming washer that was on the front. There's no shimming washer on the back. They rely on the stepped part. They rely on the step to hold against the bearing. Just set the distance, which is quite a long way. There's quite a big gap. Normally you want it a bit closer than that, but that's the way it goes. With this motor, they don't want any haven't spent any time shimming it in production. The all-important stator resistance, I'm not sure it's going to be brilliant. Just check that's at 0, well calibrated. 0.049. But 0.049. 0.049. That's for the 17.5. 0.049 all round. When you consider that the Phantom was 0.038, there's just no comparison really. This is not a good competition motor. How to tell whether you've got the modified version of the 13.5, for instance, or the spec version? Well, the only difference that I can see, and it's small, you don't notice it at first, is it says spec on that one and modified on this one, and the rest of it there is pro, all that right in there, and elsewhere including the M-bell you don't spot it, or on the actual what's printed onto the stator. So it's modified spec, so it is actually written on, and if you think someone's using one or the other, that is assuming it's not covered over where you're going to spot it. Testing the new SkyRC Ares ProV2. This is the 13.5 turn so-called modified version, which has the much stronger magnet in it. So it's not a bad strength magnet. It's not the best, but it's not particularly weak. So we set it up and compare it to the R1. Adjusting the Ares 13.5 with the end bell turned as far as it would go, right up to the end stop, which is just over 50 degrees. Just managed to get it to 6 amps, which is a kV of 3266, and the RPM was 5,476, 7.8 volts. I'll just check the timing. 50 degrees, 50, 52, 47, and on the end bell itself it gets to just over the 50 degree mark. Efficiency test of the Ares 13.5. Looking at the efficiency graphs for the Scorpion, the R1 and the new Ares. The R1 is the blue, the Ares is the brown, and the Scorpion is the green one, but the Scorpion was maximum efficiency, and it had quite a good revs. Midpoint about 16,000. Midpoint on the R1 it's a bit hard to see, but it's about 20,000. And the Ares is the brown one. That's way down, 14,000. So it's not a heavy motor. You can check the summary, and it says 58.9 at 17,356 for the R1, 64.7 at 14,448 for the Ares, and 69.4% at 15,614. We can look at some other graphs. RPM, the current. You can see the acceleration of all of them when it hits full power here. For about up to about here, they all accelerate the same, which is about just under 20,000 RPM, and it takes them less than 2 seconds to get there. But after that point, the R1, which is the green curve, storms ahead, just keeps accelerating up. It is nearly 28,000 RPM. The Scorpion has peaked out at just over 24,000, and the Ares is just under 24,000. The braking, the blue one, the Ares has got slightly better brakes, unusually. Normally the speed control is limiting the performance of the brakes, but the Ares managed to get a little bit better brakes. Looking at the amps, as you would expect, the red one, the R1, is drawing more amps to give you the more performance. The other two are very close on amps. They end up down here at about 15 amps, whereas the R1 is still drawing over 20 amps along there right when it hits the top. So if you want to, if you've got a straight where you can go up to nearly 6 seconds of acceleration time, then the R1's going to be miles ahead of the other two. I've taken the rotor out of the 13.5 turn motor, which is supposed to have one of these higher torque, and it felt like it did. Comparing it to the one out the 17.5, careful not to bang them together, you can quite clearly see that the stock rotor has a non-magnetic core in the middle, and the magnetic parts wrapped around, and the modified one has a much more of the magnetic material with a smaller non-magnetic core. The stock one also has some writing on it, and the other one has no writing on it at all. So I'll just show you that the one in the 17.5 is only about 1260 Gauss, pretty light, and the one from the 13.5, much more impressive, 1600. I'll test the 17.5 with both rotors, the weak one and the strong one, and just show what the differences are. Testing the new Ares ProV2 17.5 turns, which has got a pretty low torque rotor in it. The problem is that even with the end valve turned to maximum advanced timing, it won't actually go any further, and it's showing about 50 degrees on the end valve. I can't get it above 3.7 amps at 2823 kV. And we'll just double check the timing. Well, it says it's 48, that's as far as we can get it. And it's a spread 48, 50, 47. And looking at the end bell, I'll just show you that the end bell, you can see it's as far as it'll turn, that is just above the 50 degree. You can't physically turn it, it's got some sort of stop. Now that's with the weak rotor that it came with. So we'll test it with that one then, and then we'll put the strong one in and just see if we can get it to go any better. With the near 1600 Gauss rotor, put in the 17.5 turn, still with the end bell timing as far as it would go. We managed to get it up. Well, the revs are down, but the current's up, 4.6 amps. Rev kV's only 2491 now. The revs are really low, but the timing 48 it says. Average 50, 49, 46. Results of the test on the Ares ProV2 17.5 turn. The blue one is with the spec rotor. This is the efficiency curve. Efficiency on the left, it's about 60%, just over, at about 12,000 RPM. Now when I fitted the high strength mod rotor, high torque, the efficiency went up to about 65%. It's a very wide efficiency curve, so it's going to be quite efficient from low revs to higher revs, but the maximum point is higher. It's over 12,000 revs, about 13,000 RPM, about 65%. A few other things you can look at: power out versus RPM. Blue one is that is the torque of the normal rotor. It peaks out quite low revs, that is about 5,000 RPM, and the torque is only about 225. With the stronger rotor in, it peaks out up higher, almost almost going on for 8,000 RPM, and it's higher, near 250. And the power output, the standard one is the green line here, power output. Well, the power output peaks about here, same as the other one actually, around about 7,500. Power output is on this side of watts, it's only 165 as opposed to over 180, 185. So while all you're doing is getting more power, the efficiency is better, and the current draw is not much in it. We can tick current draw well, the two of them do about the same. So stronger rotor is giving you more power, more torque, and better efficiency without any trade-off with amp draw. Graph showing the Ares ProV2 17.5 turn with the spec rotor and the mod rotor. So the blue one is the standard spec rotor, and the brown one, this is the RPM acceleration. Well, they accelerate about the same really until we get to here, which is 16,000 RPM, and the spec one goes a bit higher, and the other one won't rev as high, the stronger rotor. But when you hit the brakes, there's much better braking force, the steeper the better, with the stronger rotor. That's what we'd expect. So as far as the current goes, again, it shows that the current is basically the same, except for the small pulse when you first starts accelerating, and they're both basically the same here, about 12 amps. So actually changing the rotor doesn't make a lot of difference really. It just gives you better brakes. As far as the rest of it goes, it doesn't really show up any increased